Okay. Oh, so welcome all of you to this class. So yesterday we have seen that the greenhouse gases absorb infrared radiation and prevent it from escaping into space and then re-radiate back onto the earth, and so the global warming is occurring. Now, we have also seen a few greenhouse gases: carbon dioxide, methane, and nitrous oxide are very good at capturing energy at wavelengths that other compounds miss. Okay, I think this is where we stopped yesterday, and now let us look the future things today. As you can see, the very important question that we have to answer is, how does a gas become a greenhouse gas? Now, in this one, you can see we have drawn a few gases. We have got nitrogen and oxygen, the carbon dioxide, then methane, and water. So let us listen to this one. Molecules with more than two atoms tend to absorb radiation more effectively than diatomic molecules such as N2 and O2. I hope you understand this one. N2 and O2, they are diatomic molecules. That is, two atoms make one molecule of N2 or O2. That has got a structure like this. This is because of the, whereas when you consider carbon dioxide, you have carbon and oxygen, two oxygen atoms and one carbon. Water, two hydrogen atoms and one oxygen atom. And CH4, you have four hydrogen atom and one carbon atom. So they tend to absorb radiation more effectively than diatomic molecule. This is because of the net balance of their electronic configuration. You might have studied in physics and chemistry, when two different atoms are joining to form a new molecule, the electrons are exchanged. And there is a balance of their electron configuration in such combinations when compared to N2 or O2. N2 or O2, two similar oxygen atoms are sharing the electrons, so there is no net charge. Whereas in this one, it is carbon and oxygen, so both of them have different electronic configuration, so they naturally will have net electrons on their outer shells. That is why diatomic nitrogen and oxygen are not greenhouse gases. So the net balance of their electronic configuration make these molecules with more than two atoms to be more reactive towards the solar radiation. Now, does it mean that all these gases, which may be similar to carbon dioxide or methane or water vapor, are they going to be greenhouse gases? Let us see that. Why do certain gases only interact with radiation? Now, these are typical greenhouse gases examples. When radiation impinges on a molecule, it can excite the molecule either by vibrating or rotating. This phenomena you have studied, the vibrations and rotations of molecules in physics in your college classes. Molecules of a particular kind of gas have a different shape from molecules of another type of gas, and so they are excited by radiation in different ways. So carbon dioxide has got a very different shape, molecular shape, compared to water or the CH4 or methane. So their vibrational energy or rotational energy, depending upon the amount of energy they absorb, this is going to be different. So all these different gases, you may find many other gases of this kind of combination, but they won't become greenhouse gases. Only some of them do become, because of their energy characteristic, which will give them a special vibration and rotation in the presence of solar radiation. Understand? So because of their varying geometries, their geometries are varying, that is, the shape is varying, different molecules and sizes, different molecules absorb radiation of different wavelengths. They absorb different wavelengths at different wavelengths. For example, CO2 tends to absorb radiation of a wavelength of 15 μm, that is micromolar. This wavelength excites bending vibration of CO2 molecule, whereas H2O tends to absorb at a wavelength of around 16 to 20 μm. So different gases have the absorption at different wavelengths of the solar radiation, and when it is at a suitable wavelength of the solar radiation, then only a gas becomes a greenhouse gas. Otherwise they don't. Many gases will have the absorption at a very different wavelength. That is why they are not greenhouse gases. Only some of them are greenhouse gases, like carbon dioxide or methane or water vapor or nitrous oxide. They are all greenhouse gases because they have got a molecular structure, geometry, size and shape, which will be able to absorb the solar radiation available at a specific wavelength. I hope you understand this now. So the next question is, how does this create the greenhouse effect? You have seen that the greenhouse effect, that is the shortwave radiations, are converted into infrared radiation, and this is repeated and then it is sent back to the surface of the earth, thereby warming the surface of the earth. Now let us read this one. The greenhouse effect occurs because the atmosphere is relatively transparent to the wavelengths of solar radiation while it absorbs infrared radiation. Now, when the solar radiation is coming down to the earth like this, it is quite transparent. It is actually freely coming into the surface of the earth. And nothing is absorbed in the atmosphere. Everything is coming into that. And then after it comes onto the earth, then when it is reflecting and reaching the atmosphere, it changes to infrared, and then the infrared is actually absorbed by the greenhouse gases. So a large chunk of the sun's radiation makes it to the Earth's surface. At the same time, the atmosphere containing the greenhouse gases absorbs the radiation emitted by the Earth's surface and re-emits it back to the surface, increasing the total energy the surface receives. This forces the Earth's surface to become warmer than it would be otherwise. Simply speaking, what is happening is that the solar radiation, most of which is shortwave, is coming down to the Earth, and then when it touches the Earth and it is going back, it gets converted to infrared, and this infrared is absorbed by these greenhouse gases and they are re-radiated back into the Earth, thereby warming the Earth. And otherwise, if these gases were not present in this atmosphere, Naturally, this infrared radiation would escape into the space and it won't come back to the earth and warm the earth. I hope now you have a very clear understanding about the greenhouse effect and the global warming, how the global warming occurs. Now you should be able to tell anyone who is asking you how the global warming is occurring because of the greenhouse gases or like carbon dioxide, methane, and other things. I am sure you will be able to do that now. Now, let us now come into a very important aspect of this story. That is it really true that the global warming is occurring? There are many scientists, especially many in the developed countries like America and Europe, who say that it is a big hoax made by some scientists. And there are people in the developing countries also saying that this is just a hoax. They want to export certain technologies. The European countries or the Americans want to really export. For example, Europe is very much advanced in solar technology. They want to export their solar technology to developing countries and make money. So they have just framed up the whole thing like the climate change and global warming, everything is occurring. So what is the fact behind it? That is what we are going to examine now. So this is called the hockey stick controversy. Now, why do we call it the hockey stick controversy? Now, look at this particular graph we have already seen. Isn't it like a hockey stick? The hockey stick is this one, and here it is the bend at the end. Isn't it like a hockey stick? So the critics of climate change really pull the leg of scientists who have drawn this one, and they call it the hockey stick graph. So that is why it is called the hockey stick controversy. Now, to understand more about it, whether we should really make fun of them, and so we should know how did they construct the global warming graph. This is a very interesting part. There is a American scientist called Michael Mann. Of course, he didn't. He did it in I think in the 1950s or 60s, something like that. This graph, and he didn't know that this would make such a big controversy. Climate change and all these things are going to be based on this. Michael Mann and his colleagues from Massachusetts constructed the graph originally in 1998 using two main sources and published in Nature. Only he published in Nature in 1998, although he for many years, he had made it after making it. Now, what was his basis? How did he make this graph? Say, for example, I told you that from the year 1000, the temperature has been drawn, and then all these years the temperature has been. How did you get that data? To draw such a graph for several centuries or more than 10 centuries, from year 1000 to 2100. So 11 centuries, how did he get the temperature data to draw this particular graph? But you know that he depended mostly on proxy records. I think in one of the first two classes I told you about the proxy records. That is, you have some historical events of climate, like a flooding or a drought or something like that, and then you draw that. And another thing is the tree rings. I have told you about the tree rings. That is, I hope you remember. They give an idea on the climatic condition of the past, which is called the dendrochronology or dendroclimatology, to be more specific. For example, in this particular tree cross section, you can see that the outermost rings are the younger ones, whereas the inner ones are the older ones. Okay, so every year from the outer side, that is to be very specific, at the outer, if you examine a ring will have a cambium and xylem and phloem on either side of the cambium, and the cambium cells are going to divide and then produce the wood, and phloem of course will divide and produce the transporting material. So this is happening outside in this tree. Now if you have if for example, look at this particular tree, it is more or less uniform, but at this point you will find that there is a color change, and at the same time you will find that the ring has also a bit, is also a bit wide compared to some of the rings here. These rings are a bit narrower compared to these rings. That means that something would have happened, some stress would have happened to this tree during these years compared to this one. For example, a drought can cause less growth of a wood of a tree, and the ring can be have a width which is much smaller than a ring which is grown during a very good rainy season, and when a year with a very good rainy season. So you can deduct many things if you examine closely. For example, see here, there is a ring here. I hope you can see it very clearly. And this particular ring you can see is very narrow. Two lines you can see if they are, say, if you try to separate them. So this means that some stress has occurred in the life of this particular tree while it is growing. So this way people can deduct or assume many things, and that is called the proxy records. Now, second, the metal man depended on isotopic ratios in the ice cores, corals, and lake sediments. Now, don't think that Michael Mann went into Antarctica and then did all these ice cores and he underwent, I mean, he went undersea and then did all the work on the corals and lake sediments. No, he didn't do any of these things. He was just a physician, a physicist. Who just analyzed the data, put together all the data created by a large number of scientists till that time. So isotopic ratios of the ice cores taken from Antarctic, I have told you that it can really tell you what was the temperature during those days. And then corals also, they in the sea, because the coral deposits, you can easily, you can subject it to carbon dating and then find out their age. And from there, the analysis of the coral shells, you can see what was the condition of the temperature at that time. These are all very, advanced type of science, scientific research going on. And lake sediments are formed in the lake one after the other, and you core into that lake and then take out the core and then analyze it for with the carbon dating and all these things. So these are all possible, and he and his group exactly did that. Based on this one, he has drawn this one. So the main criticism for people is that mostly they depended on proxy records or dendroclimatology and not direct recording. How can anyone do that? Direct recording, because you cannot go back to year 1000 and record the temperature there, because in the thermometer itself was invented 8.5 centuries later. When compared to 1000, it was only 1860 or something the thermometer came into real use. So the main criticism, the tree ring records could be reflecting any kind of stress such as drought or floods. They also get smaller as the tree gets older. So the tree ring record, say this particular record, how do you say that it is something to do with the temperature? It can be a flood, or it can be some damage happened to the tree at that time, all the leaves shed because of some disease. There are so many reasons a tree can respond to less growth when compared to a normal growth. So this is their criticism. Okay. Now, it does not show the little ice age nor the medieval warm period after AD 1000. Say, climatic scientists have shown that there was a little ice age. What is this little ice age? There was a major ice age on our Earth planet, maybe more than 10,000 years ago. The entire Earth, except the tropical areas, got frozen. Whatever was present in in different continents at that time, those organisms could migrate to newer areas into the tropics. Otherwise, they all got perished during the ice age. Now, there was a little ice age that is from around 3.5 centuries, 1550 to 1850. A little ice age was there, even in our own, not in our own times, but in the medieval period, that is 1550 to 1850. Europe and other temperate areas became very cold for 3 centuries, it is said. Now, that medieval warm, and then there was a medieval warm period after AD 1000. This is the criticism. So there should have been a lifting up of the graph here, and there should have been a downward movement of the graph here also after 1550 to 1850. But none of these things are seen on this particular graph. So the criticism of many scientists is that Michael Mann just drew that graph just from some proxy records, and it is not based on true science. So let us examine it further. Okay. I have shown you this one. This graph, this is dendroclimatology, dendrochronology, all these things. Now, a number of scientists later worked on this aspect, and they drew a number of graphs. I'm not putting the names of these scientists. Each color represents a particular group of scientists. You can see how many graphs have been drawn to examine the fact later. And you can, if you just have a very general look at it, you will find that they are almost the same. But they are not always the same. Some have actually tried to show the warm period, which is around here, and the cold period, the little ice age here, much more prominently than others. So this is the type of controversy or disagreement among scientists on this particular graph, which is usually projected for climate change. Now, let us look at a more concise form of the graph. In fact, the very prominent among these critics was McIntyre and McKittrick, two Canadian scientists who worked on this aspect, and they have drawn this red line. And here you can see the warm period after the year 1000, and then the little ice age after 1550. So very clearly it is shown, and Michael Mann's graph is here, the original, and this is the upward trend that is seen in Michael Mann's graph. So this is actually the whole controversy has been condensed into these two lines now. Some scientists say that it should have been like this red line, and there are supporters of Michael Mann who says that this is quite fine. It actually shows. Here also it shows the upward tendency of the temperature going up, not as much as here. That is all the difference. Okay. So that is why some scientists are, especially the American scientists, some of them are very critical, saying that nothing happened to this planet when the temperature went up even much higher than it is today. Today's graph is only up to here, even Michael Mann's. Whereas at that time, the temperature went up quite high and nothing happened to the Earth. At that time, more happened to the Earth during the cold period, according to them. Okay, so this is the kind of criticism. Now, let us now look at the recorded temperature with instruments and see whether the criticism about global warming is warranted or whether we can accept it. Say, this red line actually represent the annual average, and this blue line represent the 5-year average of these ones. Okay, you see the recording is from 1860. So recorded temperature with instruments, that is the thermometer, has been there, and then people have started recording. Even in India, we have got a temperature recording from almost 1860. During the British time, it started, and we are still continuing that. Okay, now here you can see that the temperature is showing a tendency towards rising from 1860. From if at all you look at 1.5 centuries ago, from that time onwards to here, you find that there is a big rise in temperature, annual average temperature, isn't it? So this is something that is happening anyway, no doubt about it, because instrumental record really shows, not, this is not the proxy records, as I have told you last. It's not proxy record, this is instrumental record, and it shows that the temperature is warming. So there is a global warming. Then there are other evidences also. Say, the natural calamities are on the increase. In this particular graph, you will see that you will see all the 5 continents, and look at the graphs for each of these continents. It is actually showing the number of floods. It is actually a graph, it's actually a figure released by the United Nations. So very well supported by good data. Now, the number of events of floods happening in all the different continents. You can see that in America, in 1950, it was something around this number less than 50, but by the year 2000, it has gone to almost 200. Look at Asia. In 1950, it was around 50, and by around 2000, it has gone to almost 350. So Africa, Europe, it is the same situation. Only in Australian continent, you find that it is not as much as it is in the other continent. But you see, you have fire. If you take the fire, the Australian continent really has a lot of problems, you know. So everywhere you find the natural calamities are on the increase. You will also know that even in Kerala, we know we have experienced a very bad flooding in 2018 after about a century. Is it not? I mean, the last flooding before that 2018, which was as grave as this one, was in 1924. We had a very grave floods, and after that, this is the 2018 floods is the gravest one which has affected the state, all for just after a century. So, and then 2019 we had floods, and 2020 we again had a real problem with landslides this year, and I don't want to say that we can expect more, but I have to say that we have to expect more. We have to be ready with it. We have to be very vigilant about it and take all the precautions in future also, because global warming is happening and climate change is happening. So there is a chance that we are going to have many more natural calamities in the future. It may not be floods. It could be a drought. If there is not going to be rainfall for 3-4 years, not the adequate number of rainfall, I mean, not complete, see, Kerala gets, for example, 3,000 millimeters of rainfall a year. Exactly speaking, 3,010 millimeters a year. Now, let us assume that this average rainfall of Kerala is going to be reduced to 2,000. It is quite good rainfall, 2,000. But let us assume that it happens, this rainfall, less rainfall situation happens for 5 years continuously. Then you can call it a drought period. Then what will happen? Many of our crops, the favorite crops of Kerala, like a coconut, like a rubber, like the spices, they will all disappear from the state, because these crops mainly depend upon the very heavy and more distributed rainfall in the state. So if you have a kind of a drought period, then we will have another type of destruction. It may not be human destruction, but crops are destroyed. Forests may also get more fire situations in that. So many of the forests, the tropical rainforests, get burned. So all these problems can be expected in future if the global warming is going to proceed like this. Now, let us look at how much warming has occurred during the last 1 century. It's not a very up-to-date record I have projected you, not from the latest IPCC report. I told you about the IPCC report. Maybe you can go into the internet and look at the latest report of IPCC. IPCC is Intergovernmental Panel for Climate Change. They produce report every 4 or 5 years, something like that. There is no such definite requirement. I think they have got a report for 2019. I am not very sure about the year, but anyway, you look at it and then find. And but in general, in over 1 century, the warming has occurred at a level of 0.85 degrees Celsius than the previous century. For during the period of 1880 to 2012, the warming is 0.85 degrees Celsius. So you may say that, is that all? Is that for this kind of a small increase in temperature that we are making so much of noise? Not exactly. It is only when we know this much temperature increase is sufficient to induce a major climate change. That you should know. Don't take it as a very small number. In our general life, we may take it as, because you know that in Kerala, for example, we work mostly at around 30 degrees Celsius, the average temperature, isn't it? In Wayanad, when you are going, then you may be experiencing an average of less than that, maybe 25 or 22, something like that. But in general, Kerala, it is around 30 degrees Celsius. And if you go to Gulf countries, Dubai or Abu Dhabi and all these places, you will find that people working at 50 degrees Celsius. They will be out in the exposed, at 50 degrees Celsius. You can't imagine, many of our people really do the work at 50 degrees. And it is terrible. Then what is there? An increase of 0.85 degrees Celsius? Is it really something to be spoken of? So this is a question that people can ask. I will answer to these questions later. But let us, before that, let us see, how do we take this controversy? We are talking about a controversy, whether there is a climate change or whether there is a global warming. We are not concerned about what happened before 1860. Let us assume that way. Everything is proxy. Everything is proxy. Let us see that the story given by man is really wrong. No doubt, the instrumental record show that the Earth is warming after 1860. I think I showed you one graph. This instrumental record is really showing that after 1860 there is the warming going on. So there is no doubt about that. The world was warmer or cooler in the past due to solar cycles. The world was warmer or cooler in the past due to solar cycles. Maybe after the 1000, there was a warming, people say, it could be due to solar cycles, isn't it? And people say, some scientists say that even today it is due to a change in the solar cycles that is coming, that we are experiencing a higher temperature. Now, greater past climate variation imply greater future climate change. Let's take it for granted that it is due to solar cycles changes that the warming is occurring. Okay, fine. But today, the threat of these solar cycles is also much higher because of the increase in the greenhouse gases in the atmosphere. If we had a higher temperature after the year 1000, then after the year 2000, we are going to have a much higher temperature increase compared to after the year 1000. Because at that time, the greenhouse gases were not present in the atmosphere, whereas today their presence is very high in the atmosphere. So we will have a double effect, a solar cycle effect, plus we have a effect of the greenhouse gases also. So this is what the scientists are warning us. Now, why do we say that global warming is mostly anthropogenic? I told you about this particular word, anthropogenic, that is human induced. Huh? How do we say that global warming is anthropogenic? The warming has started with industrial revolution. I told you a little bit about industrial revolution. Is it not something caused by man? Certainly, no doubt about it. So warming has started with industrial revolution, as you can see from the previous graphs. Then greenhouse gases are on the increase ever since the industrial revolution. It is after the industrial revolution the greenhouse gases have started increasing. And it is increasing every day, reaching a maximum today and another maximum tomorrow. Because we are burning millions and millions of liters of petrol and diesel for our transport, for our power generation, and we are burning so many millions of tons of coal for our power generation, and we are excavating so much of oil from the deep inside the earth, the fossil fuels. So no satisfactory natural causes have been found so far. Except the volcanoes, I will say an except the volcanoes, which is a natural cause. No other natural cause for increase in greenhouse gases has been found so far. Understand? So this is something we have to take very seriously. So global warming is certainly anthropogenic. So we have seen, we should see that the major global warming or the major emission of greenhouse gases occurs from industrialization and power generation. You can see the statistics of this one going into the internet, and that will help you. Then forest fire and burning agricultural waste. Forest fire is a big cause. I told you about the big forest fire happening in Amazon, big forest fire happening in California, USA, and big forest fire happening, which happened in Australia in the very recent year. So these are all major causes for it. Now, don't think that they are natural. They are human-induced ones. Otherwise, they won't burn like that. Some people say that the forests are burning because of lightning. No. In fact, these countries have investigated a lot into that. They say that 99% of the times the forest fires are caused by antisocial elements, or people who are not concerned with the environment. Suppose you are a smoker, you smoke a cigarette and throw it into the forest where you are going for a visit. It catches fire and the entire forest is burned. Fire is like that, you know. You only have to give a small flame somewhere and it catches. The whole country can get burned, the forests in a country. So burning of waste material, this is something that we all do, is it not? Because our municipalities, our corporations, our panchayats are not really collecting the waste. They are still, they left to what we would like to do, or the people like to do. And in India, we have a very bad habit that we think that we can burn away the waste. Yeah, we can burn away the waste. But at the same time, as students of chemistry, you have studied chemistry, you should know that matter can neither be created nor destroyed, but only converted from one form to another. So from the solid form that you see here, it is converted to gaseous form. And it is easily reaching our lungs. A lot of our people have lung diseases. You know, in the presence of COVID, you know that people with lung diseases have a very little chance of survival. Is it not? A lot of people have asthma. A lot of people have other suffocation problems. You know, this is all due to waste material which is being burned in public without any problem. Then we have automobiles. Automobiles are plenty. In every year, the number of automobiles are increasing in India in lakhs and millions. And of course, now we have got the Bharat Bhor, which is less polluting. We should have a pollution certificate. So to a great extent, we are controlling it, and we are also, at the same time, we are trying our maximum to switch over to electric vehicles. Let us hope that in the future we will have only electric vehicles which are less polluting and less emitting the greenhouse gases. Then urbanization, land use changes, cities with automobiles and concrete buildings. We are urbanizing everywhere. We think that we can have jobs only in urban areas. This is our big failure. All over the world it is like that. That is the thinking. Only if we create urban situations, we will have employment. But we should know that our forefathers were living on the farms. We can also live. Only thing is that we have complicated our life. So we cannot live on the farms. We cannot live a simple life. We want to have a much more stylish life. A lifestyle changes. We don't want to accept a simple lifestyle. This is the problem. So we have built big cities with a lot of concrete. So cement is used, a lot of greenhouse gases. Then land use changes are there. Cutting down the forest, we build cities. That is there. Everything is there. So the development is, we call it all development, but it is not environmentally sustainable development. That is all the difference. Economically, it may be a development, but environmentally, we say that it is not development. Okay, a natural way for increase in greenhouse gases. I have shown you some major man-made increase in greenhouse gases, and this is a natural cause. That is a volcano. Now, effects of global warming and climate change. What is going to happen due to global warming and climate change? sea level rise due to polar ice melting. When it is warming, you know that at the two poles of the earth, Arctic and the Antarctic, you will find that they have got ice caps. When the temperature of the earth is increasing, these ice caps are melting. Where does the water go? It raises the level of oceans. That is what is happening. Then wildlife adaptation problems. A lot of our wildlife are having problems of adaptation. I will give you one very simple example. Why many animals cannot get used to a higher temperature. Let us assume that you have got a small aquarium at your home. You get the fish from the pet shop, where he will put this fish into a small plastic bag and put some oxygen into it and give it to you. And if that pet shop man is not good, he will not give you any advice. So you come home and then you release that fish directly into your aquarium where you have filled the water. What will happen to that fish? Will they survive? You will find that most of the fish, especially the very sensitive ones, will die within a few minutes. Why do they do that? Because the water in which they were growing and the water which you have in your aquarium, they are not at the same equilibrium temperature. Your water might be a little bit warmer, maybe 0.2 degrees Celsius warmer, and that is enough to finish that fish. So these cold-blooded animals, which are plenty, they cannot survive when the atmosphere is warming. So the wildlife is really threatened. And there are so many other animals which are living on a feed of fish in the river. And what will happen to their food? They also will disappear. So big problem of adaptation in wildlife. Ocean acidification and coral bleaching. Another big problem in oceans. You know that this carbon dioxide, when they are increasing in the atmosphere, a good part of it will be really dissolving in the ocean. Carbon dioxide can dissolve in water. Now, what happens to that water in the ocean? Carbon dioxide will dissolve in water and form carbonic acid. So the ocean becomes a dilute solution of carbonic acid, and which will react with the corals. Corals are nothing but salts of calcium. This calcium react with the carbonic acid and bleaching occurs. The whole thing becomes white, and in course of time, the bleaching and bleaching and bleaching, finally the shell is lost for these coral creatures. All coral creatures in the sea, they all get destroyed. They have no protection of the shell. Finished. Spread of diseases, new vectors. Who are vectors? Mosquito is a vector. There's say fly, another vector. You know about so many vectors, They carry the germs, which may be bacteria, viruses, and they infect other animals, and from there, the human beings also get the disease. Chikungunya, you have heard. Dengue fever, you have heard. Mosquitoes are the vectors, And then there are some African fevers, a sleeping sickness caused by tsetse fly. So all these things are there. So the new vectors will survive in a warmer temperature. See, in my childhood, we had only two types of mosquitoes, Anopheles and Culex. Now you have got another 100 types of mosquitoes, and many of them are disease carriers, disease vectors, which we never had it in India, you see, and now they are all there. Where have they come from? They have come from African countries, some other country, We have no source. These are things which you have to work on. That floods and droughts. Say, global warming. How does it result in climate change? I have told you that when global warming occurs, the air temperature increases and air temperature will go up. And this is going to be replaced by colder air from other side, which will be carrying the clouds, and then the rains will be there. So more rains. Nowadays in Kerala, you find that there are many rainy days where the maximum rainfall is more than 150 millimeters a day. Extremely high rainfall, including cloud bursts. The entire cloud is bursting and then coming down as rain. So floods are happening. Similar way, warming can result in droughts. You won't have rain sometimes. If the clouds are not there, you won't have the rains. So drought is the result. Thereby, economic disaster. We are in the midst of an economic disaster, not only because of climate change. Climate change was doing it slowly, but now the COVID. You see how the whole situation is now complicated in front of us. Climate-wise, we have the climate change big threat above our head. And then a disease which is stopping all our economic activities, all our social activities, everything. And we are going to face a big economic disaster. See, our GDP is coming down. The entire world's GDP is coming down. Employment opportunities are coming down. Millions of people are jobless in the world. And food production may come down very soon, we do not know. Because if the farmers are not able to do the kind of work, climate change is there at one end, which is preventing a lot of problems, posing a lot of problems for them. At the same time, economic other problems are there. So the world is in a very serious economic disaster. We're going to face it. Then population risk and unsustainable development. Excuse me. So population is at risk because of unsustainable development. It is not sustainable development. Sustainable development means that the environment is respected and our development is available for the next generation. So if we cannot meet with these two conditions, it is unsustainable development. And that is happening now. And then you can see the ocean circulation is disrupting and having unknown effects on world climate. The ocean circulation, which is actually promoted by the wind, it is actually disrupted. It is going into a tandem. And then we are getting a very different ocean climate, and ocean climate determines the land climate. Higher sea level leading to flooding of low-lying lands and deaths and disease from flood and evacuation. Sea level is rising every year by around 2 centimeters, it is said. So sea erosion is coming into the land, and flooding and evacuation of people from the seacoast areas. We are witnessing it in Kerala very much, Deserts getting drier, leading to increased desertification. That is a problem in desert areas. And changes to agricultural production that can lead to food shortages. We are not yet witnessing that, but we cannot say that we will not witness that in future. Agricultural production might go down. We don't know. There is a possibility. And then food supply is going to be limited. Water shortages in already water scarce areas. So in summer we have water shortages, and if the expected rains are not coming, then water scarcity is there, starvation, excuse me, starvation, malnutrition, and increased deaths due to food and crop shortages. Malnutrition will be there, and children, especially the at a very young age when they are undernourished, they don't become healthy when they grow up. So naturally, lot of unhealthy population. More extreme weather and an increased frequency of severe and catastrophic storms. This is happening especially very much in USA and to some extent in India too. We are having cyclones which we have never seen before in different parts of our country and in many states of United States. Increased disease in humans and animals. I don't have to say much about it. We are witnessing it. More and more diseases are there. Increased deaths from heat waves. In the summer, especially in northern India, we find that every year the deaths are increasing due to heat waves. Extinction of additional species of animals and plants. Many species are getting extinct. They are disappearing totally from the surface of this earth. Plants and animals. Loss of animal and plant habitats. The place where they live, they are lost. They are unable to live in that particular place because the microclimate is not there for their safe living. So many plants and animal habitats are lost. Increased emigration of those from poorer, low-lying countries to wealthier or higher countries seeking better conditions. This is another big problem the world is facing. You know that from many Asian countries which are having a lot of starvation and war and all these things, people are migrating to Europe, America, and having a lot of problem. They are not getting employment immediately after reaching there, putting big pressure on those developed countries and the people there. And there is resistance by the people there. All these things, political instability, additional use of energy resources for cooling needs. I think maybe some 20 years ago, maybe you don't remember it. In Kerala, we used to advertise our jewelry shops and textile shops. You used to advertise with their name, fully air conditioned. Now you don't see that. The reason is that air conditioner is everywhere now in Kerala. Kerala was a state where we hardly have any air conditioner some 20 years ago. Now everything is air conditioned. Why? Not because people have a lot of money. The temperature has warmed up. And it is much warmer than it is before. Increased air pollution. That is again another big problem. Increased allergy and asthma rates due to earlier blooming of plants. Plants are blooming at non-seasonal times, isn't it? Because of the warmer condition, the plants are blooming early, and those with the pollen allergy, they will get asthma because of the unseasonal problems. Then melting of permafrost leads to destruction of structures and landslides and avalanches. This is a problem in Kashmir and also in European countries. Permafrost is the ice that is present under the soil. During the winter, the water in the soil also becomes ice, and they remain there even in summer. They will be always there. They won't melt. But if the temperature is going to go warmer, then this permafrost will get melt, and the buildings that are put on that becomes unstable, and there is a chance of landslides. Then permanent loss of glaciers and ice sheets. Cultural or heritage sites destroyed faster due to increased extremes of weather. Increased acidity of rainfall. Rainfall can become more acidic because of carbon dioxide in the atmosphere. Earlier drying of forests leading to increased forest fires in size and intensity. Increased cost of insurance as insurers pay out more claims resulting from increasingly large disasters. Our premium for insurance is increasing everywhere. Huh? So the reason is that more damages are happening. So these are all the impacts of climate change. Everything will change. So with this, I think I will close the class for today, and we can expect to meet tomorrow. And at the same time, if you would like to have a couple of questions, we have got the time, so you can ask that.